Hi and welcome to today's lesson 8.5 solving quadratic equations. Today we're going to be focusing on how to solve quadratic equation by graphing and using your calculator. Now this is the vocabulary of words that we're going to be focused on for this type of lesson. You may pause it so you can read it carefully on what it stands for. Okay. So let's go ahead and look out the main concepts of today's lesson. So key concept is standard form of quadratic equation. So a quadratic equation is an equation that can be written in the form as ax squared plus bx plus c equals to 0, where a is not equal to 0. So this form can be called as a standard form of the quadratic equation. Now, I'm pretty sure most of you should know by now what's a standard form because we've been practicing this in the past lessons. Now, one way to solve a quadratic equation from ax squared plus bx plus c is to graph the related quadratic function. But notice instead of specifying it as equal to 0, you're just gonna have y equals to the expression of ax squared plus bx plus c. You're gonna end up graphing the expression. The solutions of the quadratic equations are gonna be considered your x-intercepts. So for example, the parabola that you have here, it's x squared minus 4 equals 0. But in order to graph this on the calculator, you're gonna end up graphing this section. All right, so as we analyze the graph is intersection at two certain areas in the x-axis. Okay. The location, this one and this one are your two intersects from the x-axis, x-intercepts at 2 and -2. So this could be considered your solutions. So this is your solutions. To this parabola, which means that only those two values are gonna make the expression true. That's gonna make it equal to 0. So it could be a 2 or -2 that gonna make the expressions equal to 0. If you substitute the value of x with another value, it's not gonna provide you a 0. So that means that that's not gonna be a solution. Okay. So a quadratic equation can have 2, 1, or non-real number solutions. You only have those three options for this parabola. In the future course, you will learn about solutions of quadratic equations that are not real numbers. In this course, solutions refers to the real number solutions. The solutions of quadratic equation and the x-intercept of the graph of the related function are often called roots or zeros. So whenever a question they're asking you, find the solutions of this parabola, it means find your x-intercepts. If the question is telling you find the roots, you're finding the x-intercept. If the question is telling you find the zeros, you're looking for the x-intercept. So basically, all these clue words are related as x-intercepts right here. That's all you need to look for. Those clue words are related as finding the x-intercepts, which are your solutions. Okay. Let's go ahead and practice, go over some practice problems. Here, like I mentioned on the question, what are the solutions? So that means that you have to find the x-intercept of the parabola. We need to use a graph for this situation as well. So if we have the expression for part A, x squared minus 1 equals 0, and we graph the expression, we notice by analyzing the graph is crossing the x-axis at two locations, at this location and at this location as well. So since it crossed twice, it means that this is gonna be considered two solutions. Okay, at x, let me write down much better the x, at x equals -1 and x equals +1. So it could go through those two locations. You could also write this expression, instead of writing two things separately, you could also write it down as x equals, we use brackets in this case. So you use brackets, -1, comma, 1, and close the brackets. Okay, notice I did not use parentheses. Parentheses is just gonna be like a coordinate, like a location on the graph. But brackets, it means that it's gonna be a set of numbers. So technically these two are the same thing. If we look at part B, you have x squared equals 0. If we analyze the graph, we notice that it's only touching once on the x-axis as your x-intercept. So that means this is only one solution. At x equals 0, because it's crossing the origin at location 0, 0. As part C, we notice that x squared plus 1 equals 0. We analyze the graph and notice that it's not crossing the x-axis. So in this case, this means that it's no solution. Based on the key concept, they're calling it as no real numbers. So you could specify it as that, no real numbers, or no solution is technically the same thing, okay? So here on part C, it means that no value is gonna produce a 0. Here, it means that only the value of 0 into this expression, if you substitute x into this expression, it's gonna be true, that's gonna give you a 0. Here, the same thing on part A. The two values, -1 and 1, if you substitute it one at a time into the x, it's gonna give you 0. So that makes the statement true as well. So just some background knowledge just to let you know that that's basically what it means of finding the solutions that is gonna make equals to 0 the expression true. Okay, let's go ahead and move forward. What are the solutions? Again, this is your clue word. It means your roots, your zeros, your x-intercepts. Of the equation x squared minus 16 equals 0, use the graph or related function. Now, again, we're not going to be looking for equals 0. We're going to be looking at y equals x squared minus 16 in order to graph the expression. If we use our graphing calculator, we're going to go ahead and try something new. We're going to go a new document. If you have something on the background, just press no. You don't need to save it. And we're going to go ahead and go to option number 2, add a graph. Now here we have F1 parentheses X and then close parentheses. That information is already considered your Y equals. So those two are considered the same thing. You don't need to retype Y equals, just the expression. So here we're just gonna put X squared. Oh, sorry. Let me go ahead and correct that. Let me move the cursor this way. X squared minus 16, okay? Press enter, and we notice that parabola is crossing on two sections on the x-axis. Let's go ahead and do a little bit of zoom out so we could see a little bit of the parabola much clearly. All right, so we have the entire parabola here. Now to figure out our zeros, you could go ahead and click menu. Go to option number 6, analyze the graph, and choose option 1, 0. Here, you could just see the dotted line. You could just click on it and you're gonna drag it till the calculator tells you where the 0 it is. Clicking it again. This is your first location at 4. It's crossing the x-axis at 4. You're gonna repeat the same process, but now in the other side. Menu, analyze, 0, and again, oh, something went wrong. I was moving the graph, sorry. So you're gonna click on it, drag it, and it's giving you the other location at -4. So those are your two answers, your two solutions, your two roots, your two x-intercepts. Another way to do this without using the option of menu, analyze a graph, you could also trace it. You could use the option trace and then graph trace. And you're gonna see a circle with a cross. I usually like to call this the spider because it looks like a spider and usually spiders goes up and down. So as soon as you move the spider, notice the spider is moving up. The calculator specifies you 0 at the location -4. You could do the same thing by moving it to the other side of the parabola. And gives you another 0 at location 4. So coming back to this, we already know it's crossing at 2 sides, so it's not that one. We already know it's crossing at 2 locations, but this is only one answer. And it's not going to these 2 locations. It's letter B by going over the graphing calculator. Okay. On the following problem, we're going to do exactly the same thing. Okay, so let's go back to our calculator. Click tab, press up, and let's go ahead and delete this expression. Let's go ahead and graph the section x squared minus 6x, x squared minus 6x, and then we have plus 3 as well, plus 3. Enter. Notice the parabola was a little bit moved. Let's find the zeros. Menu, let's try the trace option now. Graph trace. Let's move the spider. It's a location at 5.45. So here you have x equals at 5.45. And then your other location, if you move it to the other side, it's at 0.551. So here we put and x equals 0.551. Yes. You can also write this expression as x equals, again, brackets, 5.45, comma, 0.551, and then close the brackets. Sorry. Again, since it's crossing twice, this means that this is considered two solutions. Only these two values makes the statement true. That's going to provide you a 0. Let's go ahead and move forward to the next question. Using a graphing calculator, solve 0 equals x squared minus 15x plus 2. Round to the nearest 100. So again, let's go over to the calculator section. Let's press tab. Let's move it up and let's go ahead and edit this expression. We have x squared minus 15x and plus 2. Enter. Oh, wow. So it's a little bit much larger parabola. We could practice again by going to menu, We could use, again, analyze graph or the trace, whichever you feel more comfortable. Let's try analyze a graph and the zeros. Click it and drag it. Our first location is at 14.9. So here we have x equals 14.9. And let's try this again. Now on the other side, click it and drag it. And here we have more numbers. Since we need to round it off, then it's gonna be 0.14. So your other values is gonna be equals 0.14. It's not negative, right? No, it's not negative. So your two expressions are 14.9 and 0.14. These are your two locations that makes this true. Again, this is considered two solutions. Okay. All right, so we're gonna be solving using square roots. So what are the solutions? Again, we're looking for the x-intercept. We already know how to graph this using the graphing calculator. You could also apply the square root method when you have a binomial. So that way it could save you a little bit of time and you can make things a little bit much faster in case you want to approach to this, in case you want to approach it this way. It's up to you. The reason we try to do this is because not all the time it's going to be like a whole number, and you might end up having large decimal places compared to this this one on the previous example. So let's go ahead and work this out. If we're trying to figure out, if we're trying to solve for x, first we need to focus on the constant. And we need to add that constant on both sides. Plus 75 and plus 75. We bring down the information of 3x squared. Since we added here and subtracted, these two will get eliminated. 0 plus 75, we have 75 here. These two expressions is considered like a multiplication, so opposite of that is going to be division. What are you going to be dividing by? Well, the 3's, because you want to leave the expression of the variable x squared since we're trying to solve for x. So 75 divided by 3. For those that are having a little bit of trouble, go to calculate, put 75 divided by 3. We get 25. So here we put in 25. Now, in order to eliminate the square from the variable x squared, you're using the square roots. This is one of the rules that could be applied, that you square root on both sides. You square root and you square root. That way that this section will eliminate by itself and you're left with only an x. But every time you're doing a square root on both sides, it's going to be a plus and a minus, whatever value you get here. So in this case, square root of 25 is a 5. What is the plus and minus? Basically, the plus and minus, it means that there's two values. One of them that it's a positive 5, and the other one is consider a negative 5. So it means that this expression is going to be two solutions. Okay? At 5 and negative 5. But this is one way to do this by the square root method. Again, if you don't feel comfortable and you have your calculator, then you could use the calculator and it could work things out a little bit much simpler for some of you. Let me go ahead and erase this. And I'm gonna go ahead and show you the information is basically what I went through in case you wanna pause it so you could read it much clearly besides what I wrote. This is what the information we went through, okay? Remember, the plus and minus must be in there, okay? Pause it if you need to review it. Let's move forward to the next one. All right, so let's go ahead and practice again based on last expression here. Since we have a minus 36 as our constant number, we need to move it to the other side so we could solve for the variable of m in order to solve for our solutions. And let me see here. Let me choose a different color. So we add 36. We add 36 on both sides. We bring down m squared equals, since this will give you 0, we don't need to put it here 0. 0 plus 36 will give us 36. We notice that there's no number in front of the variable. There's an imaginary 1 here. We don't need to divide it by 1 on both sides. So we're still gonna have the same thing. So here we could just move forward to canceling the squared. Again, by applying the square root method, we apply square root, so that way this and this will get canceled, and we only have a variable of m. Square root of 36 is gonna be a 6. Don't forget the plus and the minus. That means that you have two solutions at m equals 6 and m equals -6. This is gonna be considered two solutions. I know you're some of you probably wondering where's the flower method? Well, let me do the flower for you. There's your flower. I know most of you love seeing those flowers. Let's see. Here we have a real world scenario. Every time we have a real world scenario, we do not include the negatives. We only focus on the positive numbers. Because in real world scenarios, there's no negatives. An aquarium is designing a new exhibit to showcase tropical fish. The exhibit will include a tank that is a rectangular prism with a length of L. That is twice the width of W. So let's go ahead and label that first. L is gonna be twice as your W based on the information provided to us. The volume of the tank is 420 square cubic feet. Sorry. So you have your volume of 420 feet cube. What is the width? So we're trying to figure out our width. Okay, and we put a question mark here. I didn't like that question mark. Let me do it a little bit much clearly. Yeah, somewhere around there. All right, so let's analyze the picture. We notice that we have 3, we have L, and then we have the width. So use the formula for the volume of rectangular prism. So our volume, we know it's 420 equals, our length is gonna be 2W. So replace length with 2W. We don't know what's gonna be our width, so we're just gonna rewrite the width again. Our height for this occasion, we know that the value is 3. So let's put in height equals 3, and let's put this 3 here. Notice I use parentheses so that way I wouldn't have too much confusion. So let's go ahead and move forward. You have 420. Let's multiply everything. So you have 2 times 1 times 3 will give us a 6. W times W will give us W squared. Perfect. So now that we have this, again, this section is a multiplication. Opposite of that is going to be division. Since we're trying to figure out our W, you're only going to divide the 6 on both sides so you could have the expression of W by itself. So 420 divided by 6. For those that still having trouble, you could use your calculator. 420 divided by 6, you get 70. So here we're gonna put 70. But don't forget, you have a square here. I'm gonna go ahead and continue this over here in the upper section. I'm gonna go ahead and rewrite this. So you have W squared equals 70. Again, to eliminate the square, you need to square root on both sides. So you square root, this 2 will get eliminated. So you have W equals plus and minus whatever you have here. Let's go back to our calculator. You press Control X squared and you put in a 70. Enter. We get 8.36. So this is like an estimate, 8.36. Again, since we're not looking for the negatives, so your only answer is going to be 8.36 as a positive. So that your width is going to be this much. So you could, you basically already solved your width for this prism, rectangular prism. All right, so we're gonna have something similar in the next question. We're just gonna follow the same procedures, just a little bit different. So again, we have an aquarium is designing a new exhibit to showcase tropical fish. The exhibit in problem 4 will have another tank that is rectangular prism with a length that is twice the width. So again, before you move forward of reading the rest of the information, write it down, highlight it. So you have length equals twice your width. The tank has a height of 4 feet. So height is gonna be 4 feet. And then you have a volume of 400 feet cubic. And again, you're looking for your width. We don't know what's our width. So using the formula of the rectangular prism, we have area equals length times width times the height. Oh, sorry. Sorry. Let me correct myself. We're looking at volume, okay? So volume is gonna be length times width times height. I forgot it was a prism, sorry. So volume is gonna be 500. Our length is 2W, so again, parentheses, 2W. Since we don't know what's our width, we're gonna just put width again. Our height is gonna be 4. Let's rewrite this, 500. And let's go ahead and multiply all of this. 2 times 1 times 4, it's 8. And then W times W makes it a W squared. Again, this is a multiplication and we're trying to solve for our variable. Then we must do the opposite of multiplication, which is division. Bring down the W squared because 8 divided by 8 is 1. Then 500 divided by 8. Let's use our calculator in this purpose. 500 divided by 8, enter. They give us 125 over 2. Let's put them as a decimal. Control, enter. 62.5. So let's put it here as 62.5. Again, to cancel out the square, we do square root on both sides. Plus and minus, don't forget. This section will get eliminated. We have our only variable W. Since this is a real world scenario, we're not gonna focus on the negative, only on the positive. So we could notice by the answer choices, those are negative, so it's gonna be out. Automatic. So it's between one of these two answers. Let's go to the calculator. Control x squared, and we have this. Then we put 62.5. Enter. We have 7.90. So anything close to that is letter C, 7.9. Our answer is letter C. Okay. And that's all you do for this type of lesson. You're just finding for your solutions, you're graphing it, and you're solving it. You're just looking for x-intercepts, your roots, your zeros. If you have any further questions, go ahead and click on the other tutorial videos. Hopefully that's gonna help you out a little bit more. You may ask questions as well. Thank you for viewing this video. You have a great day and stay safe out there, okay? Bye.